Hello ladies and gentlemen, today we're going to finish up chapter 2 with section 2.7, proving angle relationships. And so we're going to start by writing an informal proof, proving how we know that angle B is congruent to angle C using our given information in our diagram over here to the right. So the first thing we're given is that segment AB is perpendicular to segment BC. So AB and BC are perpendicular. Secondly, we also know that DC and CB are perpendicular. So we have two sets of perpendicular segments. We want to show that these two angles here are going to be congruent. Well, knowing what we know about perpendicular lines, the definition says that those two lines intersect to form right angles. So we know that both of these angles should be right angles. So we can say by the definition of perpendicular lines, we can say angle B and angle C are right angles. And we know since they're both right angles, the two angles are going to be congruent because they have the same measure, which is 90 degrees. So we can get really detailed with that, and we can say they are both 90 degrees and have the same measure. This makes them congruent. So I'll just say therefore, I like using the word therefore, angle B is congruent to angle C. So there's kind of like an informal proving how we know those two angles are congruent based upon our given information and our picture over here to the right. Today we're going to talk about some new concepts. The first thing is what's called a theorem. A theorem is basically a proven statement, unlike a postulate, which was just accepted on good faith. So it's a proven statement. You think of it as a theory, like in science. A theory must be proven. A theorem must also be proven. So this theorem, the congruent supplements theorem, we always use the name instead of the number when possible. If two angles are supplementary to the same angle, or congruent angles, then they are congruent. If I were just to look at these words without a picture or any example, that would not mean very much to me. So let's use an example with our picture over here at the right. Let's say angle 1 is 30. Well, angle 1 and angle 2 are supplementary. Angle 2 should be 150 because these should add to give us 180. 180 minus 130 gives us 150. If angles 2 and 3 are supplementary, then angle 3 should be 30 because 150 plus 30 gives us 180. That means that angle 1 and angle 3 are congruent to each other. So if they're both supplementary to angle 2, they're going to be equal to each other. That's the theorem. If angles 1 and 2 are supplementary and 2 and 3 are supplementary, then 1 is congruent to 3. That shouldn't be 4, that should be a 3. Excuse me. And if you notice, this kind of looks like a property we've talked about before. It kind of looks like the transitive property, where we can cut out the 2's and just say that angle 1 is congruent to angle 3. It's not exactly the transitive, but it looks like the transitive property. It's not transitive because we're dealing with supplementary things, not just things that are equal. But, like before, we can cut out the common angle and say they're congruent to each other. So if they're both congruent to angle 2, then they're equal to each other. Theorem 2.5 is the same thing, except we're talking about complementary angles. So if 4 is complementary to 5 and 6 is complementary to 5, then they're congruent to each other. And again, it looks like the transitive property. 4 and 5 are supplementary. 5 and 6 are supplementary. Cut out the 5's. 4 and 6 should be congruent to each other. Excuse me. So that's congruent complements. Just like congruent supplements, except we're dealing with complementary angles, which sum to 90, not supplementary angles, which sum to 180. We don't use these theorems very often in this class, but on occasion they might pop up, so it's good just to be exposed to them. Looking at a review of things we talked about in Chapter 1, we're going to look at some vertical angles and linear pairs. For this problem, we're looking to find an equation to solve for x. Well, x is in this angle here. But to form an equation, I need two pieces, one on one side of the equals and one side on the other. So far, all I have is 3x plus 1. Let's use this 32. These two angles together form a linear pair because they share a common sided vertex or adjacent, and they form this straight line. Linear pairs are always supplementary. So, if they're supplementary, they should add to 180. So 32 plus 3x plus 1 equals 180. And that means we're looking at answer choice B. We're not asked to solve, we're simply asked to write our equation. Looking at a couple of review examples, just two. For number 3 here, we're not going to do number 4. Angle 1 is 112. Find the rest of them. So we're going to find the measure of angle 2, measure of angle 3, and measure of angle 4. Well, looking at our picture over here, 1 and 3 are across from each other, so they should be vertical, so they're the same thing. They're both 112 degrees. Angle 2, however, isn't vertical with angle 1 or 3. It's vertical with angle 4, which we don't know yet. But looking at angle 1 and angle 2, they form a straight line and share this common side. So they're a linear pair. So to find angle 2, since linear pairs are supplementary, you take 180 and take away 112. So it's 68 degrees for angle 2 because they're a linear pair. Likewise for angle 4, it's 68 because 2 and 4 are vertical. So if this is 68, angle 4 should be 68 as well. We did an example just like this in section 1.5. So if you want to look at the 1.5 video, that could be of some assistance as well. Last example for this video, we're going to do the one on the left. We're not going to do number 12, so let's make some room over here. It says find the value of the variables and the measure of each angle. We're not going to worry about the measure of each angle for this particular video. To keep it concise, we're going to find the the variables. So the trick is solving for x and for y. So let's solve for x first. Our x's are here and here. Well, those x's, the question is, are they linear, which means they add to 180, or are they vertical, which are equal? Well, they're vertical because they're across from each other, not next to each other. So we're going to set them equal to each other. 13x plus 9 equals 15x minus 1. If they were linear, if they were next to each other, we would add them to equal 180. To solve for x, let's subtract 15x from both sides. So these cancel, and we're left with negative 1. And on the right side, 13 minus 15 is negative 2x, and plus 9 is left on the left side. To solve for x, we'll subtract 9 from both sides. This is where students get tripped up. Negative 1 minus 9 is negative 10. Positive 1 minus 9 is negative 8. So make sure you realize that's a negative 1 still. That negative stays with it. And I divide both sides by negative 2, so my x is going to equal positive 5. So there's my x value. I still need to solve for y. Let's see if I can shrink this a little bit. I'm going to go ahead and erase the x, so if you don't have it written down, pause it. Otherwise, I'm going to erase this, and we're going to move on. I have to put in some white again, yeah. So to solve for y's, we need to identify, are they a linear pair, or are they vertical angles? Well, these, again, are across from each other. So they're going to be vertical angles. We'll set them equal to each other. If they were next to each other, we would add them to get 180. So in this case, 4y plus 2 equals 2 times 3y minus 25. I'll distribute my 2, so the left side stays the same. The right side is now 6y minus 50. You distribute to both pieces, not just 3y. And now I can solve for x. I'll subtract 6y from both sides, so my y's are all together. So these cancel, and I have negative 2y, bring down my 2, equals that negative 50. Next, I will subtract 2 from both sides. So these cancel, and I have negative 2y equals negative 52, not 48. Negative 50 minus another 2, I have a total of negative 52. And divide both sides by negative 2, So y is 26. From before, my x was 5. So there's example 11. If you need any extra assistance, feel free to check out lesson 1.5. The video can be helpful. I hope this video was helpful as well.